cancel 2 times ln 6. Now use calculator to figure out this. And the number of bacteria should be whole number, so you round it to the whole number. So get 322,517 bacteria per hour, because this is the rate per hour increased by so many bacterials. Next one, question 26. Radioactive substance decay. Now it is exponential decay. Before is exponential growth. Previous question is exponential growth. Here is KT. Now this is decay. Here is negative KT. Then will be decay is decreasing exponentially. For example, the amount of radium present at any time t obeys the law. Q0 is the initial amount present, and K is a specific positive constant, and times negative K. That become decay, decreasing. It's a decreasing function. The half-life of a radioactive substance is the time required for a given amount to be reduced to 1/2. And it is known that the half-life of radium is approximately 1,600 years. Suppose initially there are 200 million grams of pure radium. A find amount left after t years. So figure out Q of t. So figure out Q of t. So first of all, you have to figure out this K. So how to figure out this K? After half-life, that means initial is Q0. Q0. Half-life become half of it. So after 1,600 years, so t equal 1,600, plug in t, and times negative k e to the power of this. Initial Q0, after 1,600 years, become half-life, become half of the amount. Half of initial is Q0, half Q0 over 2, half of it. For example, initial is 200 milligram. Half of it is divided by 2, become 100 milligram. And you can use 200 plug in here, and then 100 plug in here is the same thing. And then cancel Q0, and you get 1 over 2. Q0 cancel, equal e to the power negative 1600k. Solve for k, get the k. So you take ln both sides. 1 over 2 is 2 to the power negative 1. Take ln equals. This take ln, this go from, get negative 1600k. And ln e is 1. So the ln e, this is actually just this. And divided this done. And this negative sign go from, get negative ln 2 over this divided done, negative 160. And then equal ln 2 over 1600. And plug this number into original function. You got Q of t equal Q0 initial is 200. E to the power negative k. K is ln 2 over 1600t. And that is the question. Find the amount after t years. Now next question. What is the amount left after 800 years? So t use 800 plug in. So Q of 800 equal 200 e to the power negative ln 2 over 1600 times t use 800 years. Plug in. Then you figure out this. And here is 200 negative ln 2 over 2. And this part, and use calculator. Use calculator, you figure out this. You can figure out, use calculator, you get this. Then, and then here's the milligram. You can round it to 4 decimal digits, or you round it to 2 decimal digits. They all correct. Now, see how fast is the amount of radium present changing after t years. So how fast? So it's going to be take derivative and figure out how fast it's changing. So you take first derivative and get 200. Since e take derivative is still e, so it's just copy this down, e to the power ln and t, which is this one. This take derivative, and that's e take 200. This take derivative since e, so it's still this. So it's 200 this. By the chain rule, u times u prime. This part take derivative. This part take derivative is just this one. Times negative ln over 1600 equal. Then you can times it. Here 200 over 1600 cancel, get 8, and negative ln2 over 8, and times with this and get this function. That's q prime. Is how fast the amount go per year is this. After t years per year goes such fast. The rate of change is this one. Then D, how fast is amount of radium present changing after 8 years? So T equal 8, plug it in. So it's Q prime 800 equal negative ln2 over 8 e to the power negative ln2 over 1600 times 800. And here's the cancel. Get this. Get this. And I didn't count it. This one, so is and you can use this one, or you don't use this one. It's okay. Let me put this way. Use calculator. So this one is going to be e to the power cancel, get negative ln2 over 2. Then it's not this. And the rest, you just use calculator. It's not going to be this. And use calculator, you will figure out this. You can figure out how much. And what I'm going to do before, because is this part. And the Q function you take derivative is still this. That is Q of this. This one is Q of t. This one is the Q of t. And times this. Times negative ln2 over 1600. Like this. You can use this one. You can use this one, plug 800 into t to do. Or you can use this one. Q prime of 800 equals Q of 800 times negative ln2 over 1600. That equal Q of 800. We already figure out is this one. It's here. It's 141.4213562. The more decimal digits, more accurate. It's accurate. So take more when you do in between. Usually we use, you can use this one tying together. It will be the same answer. So let's do again. First of all, q prime of t is q of t. This one take derivative. Since this one take derivative, since this is e function, so you take derivative, it's still e, still this. So it's still this. Still q of t times. And this like u prime, this take derivative is a negative ln2 over 1600. This take derivative is this. So it's q of t times this. If you go like this, you go simplify, you can get this. If you don't simplify it, you got this. If they are equal, you can use this one or use this one to do the next. For 800, plug in t. Got a, t is q of 800 times negative ln2 over 1600. And what's q of 800? Already figure out over here. Q of 800 is in B, figure out, and times negative ln2 over 1600. Or you can use this. This is going to be simplify, get this. Use this one. Get negative ln2 over 8 e to the power negative ln2 160 times 800 and simplify it, get this. Get this. And use calculator, figure out this. The two should be the same answer. Either way. Number 27A. Carbon 14. A radioactive isotope of carbon has a half-life of 5730 years. What is its decay constant? Find out K. Decay constant. So you figure out half-life. So formula is this. Q0, half-life become Q0 over 2 equal Q0, e to the power negative K times T. T is 5730. After 5,730 years, become half of it, become Q0 over 2. Then this Q0 cancel, so get 1 over 2 equal e to the power negative K times 5730. Then take ln both sides, so it's ln 1 over 2, go negative exponents 2 to the power negative 1 equals ln this side cancel each other, get negative 5730k. Then divide this done and get this negative go from, get negative ln2 over 5730 cancel, so get ln over 5730. What is decay constant is this one. You can leave answer like this or use calculator figure out in decimal, but this is accurate exact answer. And you go calculate, it's an approximate answer. So actually leave answer with the ln is better. Then use this, plug into the formula. You got Q equal Q0 e to the power negative K. K is this times T. And want to become and score from an archaeological site has 1/10, which is 1 over 10. The amount of C14, that is original content. Original content is Q0. Then, and here has 1/10, so it's Q0 over 10. They ask you how many years of this score. Determine approximate age. So figure out the T. Age of it. So become 1/10 of original. So it's Q0 over 10 equals Q0 original. E to the power negative constant is ln2 over 5730 times T. And ask you for T, solve for T. How age, what is the age of the subject? So, and Q0 cancel, get 1 over 10 equal e to the power this ln2 over 5730t. Solve for t. So take ln both sides. Ln 1 over 10 is 10 to the power negative 1 equals. This take ln cancel and get this. Negative ln2 over this. And t divided this done. So divided. So become divided this done. ln 10 to the power negative 1 over ln negative ln2 over 5730. That's the t. 10 to the power negative 1. Negative 1 you can go from, become negative ln 10. This with this negative and this reciprocal, and this times by 5730 over ln2. And negative sign with negative sign cancel. So you got this. And this, use calculator, figure out this. And then ask you how many years, approximately how many years. So you can round up, and you got 19,035 years. After that becomes 1/10 of it.